In this video, I will be talking about spherical mirrors. Spherical mirrors are mirrors which are formed from a spherical piece. Okay, we can see introduction. This is the figure of a concave mirror. The center of this piece of a spherical piece is known as the pole of the concave mirror. Here, C is the center of curvature. It is the center of the sphere of which this concave mirror forms a part. If we imagine a line passing through the pole and the center of curvature, then this line is known as the principal axis. Focus. Principal focus is the point to which lights parallel to the principal axis converge after reflection from the concave mirror. PF is given by F, which is the focal length of the concave mirror. Now PC is known as the radius of curvature and it is denoted by the letter capital R. The aperture of the concave mirror is the diameter, total diameter of the mirror. Here there is a relation which is R is equal to 2F. That is, the radius of curvature is twice the focal length. Otherwise, PF is equal to FC. Now, representation of image formation by ray diagrams. The image formation by reflection from these types of mirrors can be shown using ray diagrams. For this, there are certain principles. The first one is a ray parallel to the principal axis after reflection will pass through the principal focus in case of concave mirror or appear to diverge from principal focus in case of convex mirror. In this figure, it is shown. In the case of convex mirror, the focus and center of curvature up on the rear of the mirror as shown in the figure. And in here, F is the point at which the rays which are divergent appear to converge. Now the second point is a ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. As shown in this figure, when the light ray passes through the principal focus and it gets reflected parallel to the principal axis. Similarly, in the case of convex mirror also, a ray which appears to be converging to the principal focus will get reflected parallel to the principal axis. Now the third point is a ray passing through the center of curvature of a concave mirror or directed in direction of the center of curvature of a convex mirror after reflection is reflected back along the same path. In this case, we can consider this spherical mirror as being made of very small plane mirrors. In case of plane mirrors, a light which is incident on it directly gets reflected back in the same through the same path. Similarly, in this case also, when a ray of light is incident at the concave or the convex mirror through the center of curvature of the mirror, then it gets reflected back through the same path. Now the fourth point that has to be considered is a ray obliquely to the principal axis towards a point P, that is the pole of the mirror on the concave mirror or a convex mirror, is reflected obliquely. Here these rays follow the laws of reflection, that is the angle of incidence is equal to angle of reflection, that is angle I is equal to angle R in these cases. Now we can see the image formation by concave mirror ray diagrams. First one is the case when the light is coming from an object at infinity. In this case, the incident rays are parallel to the principal axis, and after reflection from the mirror, an image is formed at the focus. Now, second case is the object beyond C, that is object beyond center of curvature. That is, the object is located between infinity and center of curvature. In this case, a diminished image is formed, and the image is formed between the center of curvature and the principal focus of the concave mirror. Now, when the object is at C, an image which is equal in size is formed inverted at the center of curvature. Now, when object is between center of curvature and focus, a enlarged image is formed, that is beyond the center of curvature. When the object is at focus, the image is going to form at infinity. When the object is between focus and pole, the image formed is virtual, as shown in the ray diagram. Now, this table summarizes all the instances. That is, the position of the object at infinity, position of the image occurs at the focus F, and the size of the image is highly diminished or point sized. The nature of image is it is real and inverted. Beyond center of curvature, the position of image is between focus and center of curvature. The size of image is diminished. The nature of image is real and inverted. At center of curvature, the position of image is also at the center of curvature. The size of the image is same size. The nature of image is real and inverted. Between center of curvature and principal focus, the position of image is beyond center of curvature. The size of the image is enlarged. The nature of image is real and inverted. Now, position of object at F. Then the position of image is at infinity and size of the image is highly enlarged. Nature of image is real and inverted. Now, when the object is placed between the pole and focus, then the position of image is behind the mirror. The size of the image is enlarged and the nature of image becomes virtual and erect. Use of concave mirrors. They are used in torches, searchlights and vehicle headlights to get powerful parallel beams of light. They are used as shaving mirrors to get a larger image of the face. Dentists use concave mirrors to see large images of teeth of their patients. And the next one is large concave mirrors are used in solar furnaces to concentrate sunlight to produce heat. Since concave mirrors are converging mirrors, this property is used to concentrate sunlight to produce heat in solar furnaces. Now we can see the image formation by convex mirror. In case of convex mirrors, there are only two positions considered. That is, first is when the object is at infinity. Then the image is formed at the focus. Then the second is when the object is at a finite distance from the convex mirror. Then the image is formed between the pole and the focus, and it is a diminished image. Now, those two instances are summarized in this table. That is position of object at infinity. Position of image is a focus f behind the mirror. The size of the image is highly diminished or point sized. And the nature of image is virtual and erect. Now when the position of the object is between infinity and pole of the mirror, the position of image is between pole and principal focus behind the mirror, and the size of the image is diminished. The nature of image is virtual and erect. In case of convex mirror, the nature of image is virtual and is always erect. And this property is used, they are used for making rear view mirrors in vehicles because of this property. That is, they always give an erect image and a wider view compared to plane mirrors. Now, sign convention of reflection. The first one is the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. As we have seen in all these figures, the object was placed on the left hand side of the mirror and the light coming from the left side was considered. All distances parallel to the principal axis are measured from the pole of the mirror. Now all distances measured to the right of the origin are taken as positive, while those measured to the left of the origin are taken as negative. Similarly, distances measured perpendicular to and above the principal axis are taken as positive, while the distances measured perpendicular to and below the principal axis are taken as negative. These are shown in this figure. That is, in this case, height upwards means positive. When direction of incident light is positive, while distance towards the left in the case of reflected light is negative. And the image formed, which is inverted, is height downwards, then it is negative. Now, mirror formula and magnification. These two are the important formulas in case of spherical mirrors. The mirror formula is given by 1 by V plus 1 by U is equal to 1 by F, where V is the image distance, U is the object distance, and F is the focal length of the mirror. Here image distance means the image at which the image is formed from the pole. The object distance is the distance of the object from the pole of the concave mirror. Now magnification is given by height of image divided by height of object. And in terms of image distance and object distance, it can be expressed as minus V by U. In case if the image is real, then magnification is negative, while if the image is virtual, the magnification has got a positive sign. And this is the end of the video. In this video, I have discussed the major image formation by both types of mirrors, that is concave mirror and convex mirror, and have discussed about their uses as well as the formulas for magnification and the mirror formula. If you have got any doubts in any of the topics that I have discussed in this video, please comment in the section below. Thank you.